This is actually streaming. I hit go live. Just okay, we're good. It's fine.
Yeah, we're good.
Anyway, we have to legally show this disclaimer now.
Yay!
It's great. Just as we're a registered student organization. Registration doesn't mean the university approves of us. Which sign attendance fees for voting purposes.
They don't. Like it's just kind of implied that I'm here.
It is. Yeah, sorry, it's only implied for me.
Oh damn.
Yeah, I'm sorry.
Yeah.
That's how it works.
Shit, that means I can be president.
Everybody good? So everyone. Let me skip this. All right. Reminder. We talked about CTF that we're gonna run in what, February? Yeah, that sounds right. Basically, I still need people. So if you're interested, I guess talk to me after again. We'll come to Ops tomorrow with you. It works. The operations meetings will actually do other meetings. Those are bi-weekly on Thursdays. CTF. Codebreaker starts tomorrow. Super excited about Codebreaker. It's always good, and it's always something fun. Favorite was like 4 years ago. They built Terror Time. Terror Time was basically just this messaging line. It was great. I'll just tell you a lot about the challenges are themed, and it gets pretty fun. So.
Also, forgot to put an announcement up there that OSU CTF, I believe, is starting this weekend. So
Aggressively scared.
we're going to do that. I'll put an announcement out later.
Yeah, and then NCL. Yeah, that's going. We're trying to get money from the university. We'll see how that goes. But we'll register. Yeah, I just don't have a timeline on when that money's coming out because university. Let's see, Dragos. That's what we had a team for that. It's a little bit more defensive-ish, OT-ish, industrial control system than those CTFs that we've done. What?
No idea what to expect. It just sounded.
Exactly. Yeah. And then AQCs on November 4th. We actually run AQCs. It's usually pretty fun. It's a little bit more introductory than it's not too introductory. It's sometimes introductory. I don't know. Depending on how Chad's feeling.
Yeah, I'm feeling pretty good this semester, so.
Oh, yeah. That's good. Yeah, you'll also see similar problems between make and revs CTF. Just those pure again. Queen City Con. So Queen City Con, basically, is anybody familiar with B-Sides? Okay. B-Sides is like regional security conferences. So Cincinnati doesn't have one anymore. In theory, it does. I don't think we've had a B-Side Cincy in 4 or 5 years. So Queen City Con is coming to replace it. We'll see how it goes.
And so their registration is $50. Normal tickets are like 200. So it's a pretty good deal. I might go. I know like people I work with are going, so it's supposed to be a good issue.
Yeah. So if you want to go, that's going. I don't know if we'll go.
That's fine.
Not sponsored the cost, but no. We'll figure out. Oh boy. Operations meetings. So, bi-weekly. We moved from weekly to bi-weekly you might shift back depending on workload. A lot of stuff's kind of gotten added onto this, so if you notice the Bearcat CTF stuff, a lot of the actual prep for that is run out of the operations side, mainly because a lot of that work is on the operations side, not necessarily the technical side. It's just kind of is what it is. But main things that need for that: finance, and public affairs. Finance is specifically a great way to get involved if you're interested in going becoming exec. Just a quick info. Public affairs is fun. It's a lot of just things like our outreach stuff, going out to high schools, recruiting, which if you've worked there, that's what that is. And then I think retention falls under that. We haven't done. Right? Retention falls under
Yeah, he has retention.
Yeah, retention. Sweet. We haven't done this in a while. Those are fun. Social events. And then social media, and technical live streaming.
Yes, so the operation meetings are bi-weekly, so does that mean that it would be happening like?
It's happening tomorrow. So right tomorrow, and then we'll skip 2 weeks. Or it's gonna be. Can't remember. It's fine. Yeah, any questions? Anything you want to talk about before? Cool.
Okay, so first thing, remember how a couple weeks ago I was talking about how the ICC has like outlined some language like cyber warfare? Well, guess what? They had a cyber incident. Wow, shocker. Staff and lawyers were affected. There's been no official attribution, but take a guess. Who's committing cyber war crimes right now? Pizza Hut Australia had a data breach. I could not find any information other than the fact that it was like almost 200K customer information was leaked, and it was like everything but like the credit cards and like all that stuff, like kind of like redacted of sorts. I don't know. I just thought it was not. So I think I might have mentioned this a little, like to research something, but threat actors are moving away from like traditional Microsoft Office files and phishing emails, and they're going to ISO.rar, which are like archives, like zip files essentially, .lnk, which are pretty cool actually, and OneNote files. So kind of just a new trend in phishing stuff is looking out for. Along those lines, there's more sophisticated phishing as a service kits. So if you don't know, a lot of these like phishing emails you get are templates essentially that people make and sell to other people to distribute mass amounts. Before they like this was first starting out, they were very basic, very easy to find, not that crazy. However, they're getting more complicated, and they're using something called domain generation algorithms, which are essentially just they're generating domain names that are not as easily detectable. So like if someone's phishing UC, they might use UC or Bearcats, like Bearcats with 3 or something in it. But now it's just using some random string of characters that's like obviously looks weird, but no one like if you're looking for UC specific phishing domains, you're not gonna find it because it's gonna be like 20 characters long. So that's pretty cool. This research company called Comparitech did a study, and they found that in the past year, downtime caused by ransomware in the education sector was resulted in about $53 billion worth of losses. So that's high schools and universities. So a pretty large number there. There's been a thing going around for the past month or so for software called Moovit. It's basically a file transfer software that a lot of companies use for file transfer stuff. They had a very critical vulnerability, probably like 2 months now. It's been a while. People still haven't fixed it. So there's constant data breaches, and there's been more pretty big companies leave as well. It's like everything. So cool stuff. I'm gonna skip the after talking about now, just because the MGM sort of return to full operations. They said like their consumers and things are back up, but there's been reporting that some workers there have said that some of the things are still slow. So this is not like a new thing, but I read an article on it, so I thought it was pretty cool. So China has been very involved with building Africa, like, third world countries, their infrastructure, and giving them, a way to kind of progress in the world. And what they've been doing is like, they give all the workers all the materials as like a loan essentially. And if these nations in Africa don't do something China wants, then they, punish them, I guess. So obviously, as cyber and security has become a bigger thing, it's kind of been shining a light on this issue because all of the technical hardware and whatnot in Africa are all Chinese-owned companies, and they are almost like they're just like free. So it's not only a monopoly, but it's a monopoly in the same country. Which, yeah. So the thing is like, if these threat actors from China know what the Chinese companies are making, like their hardware, their routers and whatnot, then they know how to break into these African nations. And it's kind of like this, catch-22 of like, okay, well, they can't do anything, they're screwed. But the thing is, they can't really get out of it because if these nations are like, okay, no longer want these cheap routers, and China's gonna be like, okay, no more internet, and then now what, right? So that's great. So there's this creation of this group called Under Monitor Regions Working Group, which is kind of going to address this issue. We're going to read more on it because I just ran on what I remember. It's an article that was written by Sentinel One, so actually it's very interesting. Yes.
ZRWG, Sentinel-1, or is it government or?
I think it's Sentinel. Pretty sure. So not as large scale as one micro, but still. And then just a few more things from the Russian Ukraine things. A Russian group, no name, DDoS, they came into the border control, airport sites last weekend. So that's great. And there's also been a shift in Russia's targeting in Ukraine. The Ukrainian, I forget what's their title, but someone high up in the Ukrainian government said that they're shifting from like electrical power and we're now actually going after law enforcement agencies, which kind of goes back to this whole like ICC thing. So I thought that was an interesting tie there, but yeah. Does anybody else have any news from cyber they have? Yes.
I just found this now. Apparently, the NSA released something about a Chinese actor named Black Tech having stuff in routers about the Chinese government to like do stuff.
Yeah, that's honestly probably exactly, that's along the same lines as after things. There's always, I think I did see something about that. I don't want this, really don't want this to be like this actor, this, actor, this. There's so much stuff. There's a bunch of affiliates and actors that were really active as well. Yes, Sony did get hacked. I saw someone put that in this. Put that in this. Is it Mark? Okay. I saw that. I looked at it. There wasn't enough information there. Did you not post it?
I did, but like, there's not enough.
Yeah. It's okay. Yeah. There wasn't much information. It's all like rumors, but I did see that. Yeah. It'll probably be on here next week. Yes. Cool. In case you were here last week, Chad did an introduction to reverse engineering, and that's what it's called, right? Actual code challenge. Okay, he did. If you look that up, or what's on YouTube,
I do it basically every year at this point. But Codebreaker begins tomorrow, so I want to give a couple of hints and tips from the few years that I've done Codebreaker. So Codebreaker is a series of challenges made by the NSA. They increase difficulty throughout them. They've got some realistic flags now. If I remember, originally the flags tended to be a bit more gamey, like similar to CTFs, where you had some kind of slug and then you had something that looked weird. Now it tends to be more, hey, tell us like what IP address was the attacker coming from, or what account got compromised after you are sifting through logs, or search Windows registry file and figure out whose credentials those are. Or one of the later challenges was analyzing ransomware and decrypting ransom files. So it's pretty fun challenges. My biggest tip really just all boils down to documentation and keeping track of the description of challenges, files you're given from them, and what you're trying to find. Because sometimes I've had it where I'll start going through a challenge, forget what I'm trying to find, get lost in some rabbit hole, and spend a few days looking for that, whereas you could have just solved it. And after you solve each challenge, generally the description and files that you got from that challenge actually go away on the Codebreaker site. So that's why I say you should probably try and keep documentation of that. I like to keep a log of what I'm doing for the solution, just because some of these challenges can, you can be working on them for a few weeks every once in a while with some of them. That's typically more the later challenges, but still a good practice to get into. Yes.
How long does the whole challenge go for?
If I remember correctly, it goes from the end of September to sometime in the middle of December. Or, well, it goes from tomorrow to, yeah. In previous years, it started early August and then would go to middle of December, but yeah, normally there's going to be a couple months. I also keep a copy of files that I download. Sometimes you're going to modify those files, and keeping the originals as a copy just tends to be good practice for if you ever need to look at it in the future. And some of the challenges are also going to get you files. In last year, some of the challenges involved connecting to a website and then pulling a bunch of files from the website's backend, and you needed to keep those files because then 2 challenges later you would then use those files to then solve a different challenge. So this is kind of the general structure that my files or my folders follow. I tried to write them down. It's a little bit difficult to show in a PowerPoint, but I have a description file, solving file, which is just a log. I have an original directory, which is all of the files that I downloaded, and an image. The image directory is more if you're interested in doing a write-up. You want to be taking screenshots as you're going along. But yeah, please don't cheat. Generally, they have in their rules each year, they've changed sometimes. Sometimes they allowed for groups to work together and allowing for differing levels of cooperation on different challenges. Some of the challenges they designated as individual challenges, most of the later ones. So the next week I'll probably put another slide in for some of those rules. You can ask, if you are going to answer people's questions, try not to just give them the solution, as first and foremost, Codebreaker is a great way to learn more about cybersecurity and doing some of these different things. So, yeah, don't hack stuff. I know it's kind of funny, but in past years, the two major things I've seen go wrong for some people is the use of a tool like Durbuster, where basically it sends a lot of packets to a website to try to figure out different directories that the website has. And people got IP blocked by AWS because of that, because they host some of their stuff on AWS. And so the challenge creators can't really do much about that.
So is that not allowed?
I mean, you can do it. It's probably not. Generally, most web challenges, it's not. The solution is not brute force it, but yeah, I wouldn't recommend it. Brute forcing answers, don't do that. 2 years ago, I think now, there was a challenge that had an answer that we could feasibly brute force. They caught all the people who did that and then took away their points. So don't do that. And use Codebreaker help if you need help and you're not able to find help with either executives or other people. Codebreaker team is pretty nice about answering questions normally. And don't put solutions on our Discord or the NSA's Discord for Codebreaker. Kind of,
Get arrested.
yes, the NSA will just break down your door, and they actually have this new tool to just reach out and handcuff you from your keyboard. So,
Then they have us
I've heard the
carving
answers
down
are
doors.
classified.
huh?
I've heard the answers are classified.
That would be bad. So, get more information next week. Now, on to the intro to binary exploitation. So, binary exploitation is a category of CTF challenges. Typically, this one will be called Pwn. Don't even remember where Pwn came from now that I'm trying to think of it, but yeah, it's very old and kind of just normal. Typically, the challenge will have binary hosted on another machine, which they'll be executing, and you can connect to that with Netcat, and you're trying to break stuff. And yeah, the challenges can vary because some of the challenges, it's going to be more just breaking memory, and sometimes it'll be more overriding certain variables, other times it'll be trying to get code execution. It can vary a lot. We might go over it later on in the semester, some of the other code execution parts of it, but normal challenge, get a binary, reverse engineer that binary, find a vulnerability, exploit it, and profit. You know, pretty simple when you say it out loud, but tends to be harder in practice. Each challenge tends to have its own gotcha that will cause you problems. So, yeah. So what are vulnerabilities? So one of NIST's definitions of vulnerability is a weakness that can be exploited or triggered to produce an adverse effect. It's one of a dozen different definitions that I found on their page, but yeah, it's pretty broad. Not all weaknesses are vulnerabilities. Most of the CTFs, most weaknesses you find are going to be vulnerabilities that you can use, but some examples of them can be the validation, failure to validate user input, buffers being overflowed, and insecure deployment of file containers. Different stuff. I kind of wanted to give a different way of thinking about it because a lot of vulnerabilities tend to happen when people make assumptions about security, and those assumptions don't actually match reality. Some assumptions that I listed below, one of the fun ones is of SQL injections, where people assume that user input can't actually change an SQL query to do something else, like say drop tables or bypass a password check or things like that. What we'll be talking about more today is buffer overflows, and so interacting with the 8th index of an array with 7 elements doesn't always cause a seg fault. Sometimes it does, but a lot of times this also lets you right out of bounds. Yeah. So exploits the definition of it tends to be code or other user input that's used to take advantage of a vulnerability. There are lots of different names for different specific exploits, and you'll use a lot of them if you do CTFs. So talk about buffer overflows now, which is what this presentation is more going to be about. Buffers are arrays which store stuff. Typically, it's going to be temporary storage for user input. So if the binary is trying to read user input, that'll go into a buffer, and then that would be somehow interacted with. When you access outside of arrays, you get undefined behavior. Stuff can crash. You can get, if you do it right, you can get what's known as arbitrary execution, which is where you're able to execute any code you want. And other times you get out of bounds reads or writes, where you're accessing outside of the memory's or outside of the array's bounds to be able to read or write. So included here, a fairly simple buffer overflow that we'll be looking at for the demo. One of the worst functions to use is getS, because this function will read a string until that string that's being read ends, and it doesn't take into account any length consideration or much else. So another way that you tend to get buffer overflows is with for loops or while loops that are doing that similar idea of where they're reading for some character and that character never arrives inside of a certain number of iterations.
The man page for getS literally says at the very top and underlined, never use this function.
Yes. It's the only function I've seen that actually has that warning, so you get the hint there. It's funny too, when you compile code that has getS in it, the compiler also warns you, please don't use getS. Yes.
So why is it celebrated?
Compatibility, because some program somewhere might still use it.
So, because C is so foundational, it's been around for so long, it's basically in everything. So, key example, they can put it on aircraft control systems, for example.
You can't update that because it was running 24/7.
You can, the problem is, there's like a bunch of approvals you have to go get, it's just handy from a compliance perspective. So most people don't, usually for industrial control systems, for anything embedded, once it's in the field, they don't touch it. Unless it's something like, oh, this could, light a building on fire. Like that's the case where they'll go in and fix it. If not,
But a plane falling out of the sky, not a reason to update. And we need to shoot a demo, so let's see, hopefully this works.
This is the hard to get.
Show. Did it show it?
there's that.
Oh, yeah. Okay, so the first one we'll look at right now is just the basic overflow that I talked about earlier. So what we can see is that we've got a volatile int, which all the volatile keyword means is that it tells the compiler that this variable might be altered outside of what the compiler might see. So basically the compiler's optimizer doesn't remove that variable since we're not currently using it in this program. But go to, in the terminal, we go to this program. You can see we have our character buffer. Above that, we have the integer in that. And what's going to happen is that this buffer is going to be stored in such a way that when you write, if you write over this buffer, it'll start to write into this variable. That won't always be the case, but it is for in this case. So you can see the lovely, it's interesting because there's two, because getS is included in stdio, but it seems the GCC compiler doesn't care and just tells you anyway that this function doesn't really exist or warns you.
Everybody who's not a C developer. GCC.
Sorry. GCC is the Linux C compiler, one of them. It's GNU C compiler, if I remember correctly. Yep. With GNU being a just nonprofit that deals with a lot of stuff in Linux. So, yeah. So we get this. We can also see the lovely warning. The getS function is. Oh, sorry.
What is the make command?
Make is, let's see, make is a command that is for build systems. I haven't thought about how to describe it, but basically it's a way to have shell commands that will build a program.
So, another way to put it, basically you're putting instructions into a file of how you want something to be made. And then it goes boom and does it.
Yeah. So in this case, there's a lot of variables being used, but normally you have the file name is basic overflow, so you have basic overflow as a target, and then under that you're telling it what shell commands to run, which can change depending on what exactly you're needing. But it's just an easier way to do that instead of having to remember the shell commands that you need to run for it. So if we were to run basic overflow, it asks for input, you put input, and you'll see it prints, that's not the same. You'll see it prints the vulnerable value, so that integer before and after the getS. And what you know, strangely enough, the integer is not the same before and after we read in the buffer. So one of our alumni, Christopher Morrison, built a different program that helps to visualize it a little bit. Go over to there. So a quick overview of his code. What's going on is he has a similar setup of having the overflow integer as a local variable, having the buffer, and then it is going to, instead of this time using getS, it's actually just going to be going from an index of 0 all the way up to 19, or all the way up to 18, and is going to be overriding inside of the variable, inside of the buffer. So what you get, also this printf is going to help show what's happening inside of memory. So each of these are going to be located inside of memory. It's easier to show here. But so what you see is with each iteration of running this, at I equals 0, obviously the first character is added, all the way up to I equals 14 where the 15th character is added, and the buffer is a buffer of 15 characters. After that point, we then ask to write into the 15th index of the buffer. Yes.
So there's no seg call?
Yeah. And I believe that there's no segfault irregardless of setting those stack protections. In this case, because we aren't, what the segfaults typically come from is from trying to access memory outside of your program bounds.
Oh.
So basically, when a program is loaded into memory, the operating system, it kind of knows where the program is supposed to be looking in memory. And if the program starts looking outside of that, that's not really good and violates a lot of security principles in operating systems.
And so it's gonna come in and just.
Yes, it just nukes the program. So, but the problem becomes is that with a lot of the design of C is meant to be fast and assume people know what they're doing. So in the event that you're overwriting buffer and you're not going into unaccessible memory, you just start overwriting local variables. So you can see the overflowed int with the 15th character is written with an A value. So now the overflow integer equals 65.
So there's straight up no protection to stop you from going outside your buffer, or outside your array.
Well, there is if you go outside of your array into a different program's memory.
Yeah. If it's the same program, no, that's all good.
Yeah, and there's also a couple other protections where things called canaries might be in place sometimes, which I actually need something to showcase a little bit of how that works. And that generally is what actually is protecting the rest of your memory, because the canary will be a value that'll be there, that'll be checked after a buffer is written to. And if that value is different, they know that you overwrote the buffer. But, so as you can see here, going all the way through, and we end at writing 4 characters because otherwise we start to get into the territory of needing to be very precise, because otherwise you start to mess up.
Other programs.
Well, technically this program, but
Oh, the return address.
yeah, stuff like that, but when you start doing that, you start to have to actually, like, really know how to prevent stuff from going wrong. But,
You're able to overwrite the return address, you can do some really fun stuff.
yes, we will talk about that at a later date, though. So, the next thing I wanted to show was a different kind of challenge that I've seen around sometimes. Sometimes this challenge will show up as a reverse engineering problem. Sometimes this type of challenge will show up as a phone problem. But the general way this challenge goes is that you're gonna have a password. In this case, you've got a main function which is going to ask for, or is going to go into checkoff. Checkoff is going to have password and user input. And this password is going to be made up of random characters in this case, but you can kind of replace this with any generic thing to get password. So if you were to try it normally, actually, let's get rid of this real quick. Oops. So we can type whatever we want, and obviously we don't get anything because how are you going to guess this password? But if you notice when I ran the make, what is happening is that our input is being used with getS. So once again, we can write as many characters into this. And I also added something into it to try and help to show what's happening in terms of buffers. So we look at the password terminal. Let's go ahead and just enter a password. So what we can see here from the function so this function, all it's doing, or right here, is just printing the input, the values of input, and the values of password. So we can see that we have a normal string of what we put in, and the password was something else, don't really know. So if we run it again, and we write a bit longer, you see we got another buffer overflow. And similar to last time, what happened is that we wrote into the password buffer. So where the password is getting stored is now being written to by us, which obviously is not really good. Now, the problem we're going to have is that to actually do this, it's going to be annoying to do this with just with the keyboard, because you're going to have to like put in an exact number of A's. You're going to have to enter in unprintable characters, and then you're going to have to put in some other exact number of A's. So instead, we can do a fun thing called use Python. In this case, we're not actually going to be using Python for too much, but we're going to be using the -c command in Python, which what that does is allows us to evaluate Python code, if I can type, and a shell. So what this is doing right here is just running the print command with a string that's being concatenated 3 times, which just means that A is being added up 3 times in the string. So what we can also do is we can change this 3 times to say 17 times, and we can use the pipe operator in Linux, which means that the output of this is going to be put into the input of the next program. So if we do that, we see that we didn't have to enter in anything into the password when it runs into the password executable when we ran it, because the output of this went into the input of this, and now we got 17 characters inside of here. So the other fun thing is that we found that we accidentally made it so the password is that it says the password is A afterwards when it prints the password after you attempt to put in the correct password. So that's because it's reading. It's because printf is evaluating the string as C strings are normally evaluated, where it reads printable characters all the way up to the null byte, which is
then
0 byte.
the null byte at the end of the.
Yeah. So in this case, so the function of getS is that after it finishes reading, it's going to append whatever string it got with the null byte. So how can we use this? Well, we can use this by, instead of doing 17, we know that the buffers that we have are all 16 characters long. So we could put in 15 A's, put in 1 \null, which all that is that's a way of representing the null byte as with the string. We can put A in again 15 times, and then we can just try and see what that does. And as we see, because with Python outputting, we get 15 A's with the null byte, followed by 15 A's, and then getS is kind enough to append a null byte onto the end of that. So even though we don't know what password we are getting, we're able to successfully guess the password by just telling the program what the password
You
is going
control
to
what the password is.
be. Yes. Then not sure I have enough time for the last demo. So we're gonna end it off there. So hope or does anyone have any questions about what I've been going over so far? Or want to have anything explained more? Anything like that? Yes.
So the use of the Python script, is that just for simplicity's sake? Or is it because could you technically set it so that you would just type A 15 times, add the null byte, and then put another 15A? Or is it just because it's not really feasible to do without the Python script?
So in this case, it isn't really feasible to do without the Python script because of the fact that the null byte is literally 0. And at least on Minekeeper, there is no actual thing that outputs just hexadecimal 00.
Basically, your
But-
keypad 0 is different from
Yeah.
like 0, 0.
Yeah. So it's not really possible. And if I remember correctly, I'm pretty sure GetSD references backslash. I would hope that it does. I would assume that it does. And if you can't actually put in any backslashes, there's not really a way to put that into it. I think maybe technically, if you were to copy and paste some other string that had the null byte in it, you might be able to do that, but it tends to be knowing how to use Python or other shells or other shell commands to create a string like that is a pretty good skill to keep and be using, because especially when you start getting more complicated things that you're having to put in, tends to be the more useful side. So probably talk about some other tools later on that will also be on that line. Yes.
Out of curiosity, what happens if you just put in 32A?
Let's see. I assume it's going to. Yeah. So what's happening here? Let's see. Okay. So what's happening here? I don't feel like counting that in both ways, but what is happening is it's going to be overriding all of input, and it's going to be overriding all of password, and then there's going to be a null byte right after password. So when the string compare is done, input is going to be read as 32 A's, and then a null byte, and then password is going to be read as 16 A's with null byte after it.
Just for fun, do like 1,000.
So in that case, that basically is because we kind of just overwrote literally everything following this, and C does not have a good way to deal with that. I don't think any operating system really has a way to deal with that when you're just writing into raw memory. So, yeah. Anything else anyone wants to see? No. Alrighty. I'll still be around after if you want to talk.
Ice stream.
Bye, chat.